Researchers in Berlin have succeeded in curing a patient from HIV. He went down in medical history as the Berlin patient. This has only been documented in 6 patients worldwide. Now they did it again, although there are a few differences to the process this time. How they did it? In order to understand this, I will need to walk you through how the virus enters and replicates in the body, as well as how it is currently being treated. First, some historical background. In 1981, clinicians in New York, San Francisco, and Los Angeles recognized a new immunodeficiency syndrome in homosexual men. Initially, the syndrome was called GRIDS, for Gay-Related Immunodeficiency Syndrome, which was later changed to AIDS by the end of 1981. Soon it became apparent that it was not only confined to a segment of the population, but also in other individuals, like intravenous drug users, blood transfusion recipients, infants born to infected mothers, and high-risk heterosexuals. The virus has been identified within 3 years of the first recognized cases. HIV, the retrovirus that destroys the body's immune system, does that by taking over and destroying CD4+ cells, also known as T helper cells. T helper cells are necessary for normal immune function. To be detailed, the virus does that in a unique and really fascinating way. It takes over CD4+ cell by attaching to specific receptors, then fuses to them, enters the cell, incorporates its own RNA into the cell's DNA, and eventually uses the CD4+ cell's DNA to reproduce larger amounts of HIV, which are released into the blood. Now, isn't that fascinating? One specific receptor which the virus uses is called CCR5 receptor, and remember that. Traditionally, there is no cure. The treatment relies on medications which decrease the amount of the virus in the body, but they do not eradicate the HIV virus. What they essentially do is interrupting the HIV replication process. Now, since the only way to treat HIV is to reduce the replication of the virus, how did researchers in Berlin successfully cure HIV? The method they used to eliminate the virus from the body was stem cell transplantation. In this procedure, stem cells from a healthy person are transferred to the patient, in essence replacing the patient's immune system. The treatment is only an option for patients who develop leukemia or lymphoma that does not respond to chemotherapy alone, in addition to having HIV. It also is a risky procedure, carrying a mortality rate of 10%. Previously, it was believed that the stem cell donor has to have very specific genetic characteristics. That is, they needed to be immune to the virus. How can one be immune to HIV, you ask? Well, there are some people, about 1% of the European population to be specific, who carry a mutation in the receptor needed by the HIV virus to enter the cell. This receptor is called the CCR5 receptor. The mutation in individuals prevents the virus from entering their body's cells. As a result, these people are naturally immune to HIV. So, if it is possible to find a stem cell donor whose tissue is a match for the recipient and carries this specific mutation, then not only the patient's cancer can be cured, but also their HIV. This principle has been demonstrated back in 2008. This time they might have succeeded again, although using a slightly different approach. They found a donor who carried 2 versions of the CCR5 receptor, one being normal and the other one mutated. The transplantation had been successful in curing HIV after the patient discontinued the recommended antiviral treatment on his own in 2018, despite of the donor herself not being immune. The patient's immune system is functional, without any detectable cancer cells and any indication that the virus remains. But how could that happen? How could the patient be cured, even though the stem cell donor wasn't immune to HIV? It is considered a surprise even by the scientists, since they tried this method with involving donors that were not immune, and in these cases, the virus was replicating after a few months. What all this points to is that perhaps the cure is not only attributable to the donor's genetic CCR5 receptor, but to the replacement of the patient's immune system with the donor's one, meaning that all the places where the virus was hiding have been replaced and making it impossible to infect new cells. Why exactly this stem cell transportation led to the patient being cured from HIV is still unclear. The speed in which the new immune system was replaced might have played a part. It was done in less than 30 days. But also the immune system of the donor might have had special characteristics, like highly active natural killer cells. This discovery might be a breakthrough in HIV therapy and may lay a groundstone to develop new insights for future treatments, like cell-based immune therapies or therapeutic vaccines. Now, that was it for this video. I hope you enjoyed it. If you're interested to dive into more novel medical groundbreaking topics, don't forget to like and subscribe to this channel.